set up. Hello, everybody. This is Alfonso Verde for lab number 4, Oscillations for Physics 2211. Yes. Okay, so some background information that we need in order to deal with these oscillations of the spring would be things like the energy principles and momentum principle. And so that would basically be that the change in energy equals the change in kinetic energy plus the change in potential energy. And then you can find kinetic energy or the change in kinetic energy by doing 1/2 mass times velocity final squared minus velocity initial squared. And that would be for circular motion. And then the momentum principle would be the velocity final equals velocity initial plus F net over m delta t, the usual. And then momentum final equals momentum initial plus velocity times delta t. Yeah, perfect. And then other useful information would be stuff like the spring force, which is negative k times s times l hat, and s represents the magnitude of L minus L0, so L minus L naught, the uncoiled length of the spring at rest, minus whatever compression or change it has. Okay, and then let's look at some tracker data. So this is my tracker set up to run like this. We can see the oscillating motion between both the x and y. I'm pretty sure either I mess up a little there or it doesn't oscillate there. And then we put that into the CSV file that after a lot of arduous work, I hate glow script, it finally got to work. So let's pull up the glow script. So let's take a look at the code before anything. So we set our constants, which would be gravitational force, the spring and constant we have to solve for, along with L naught and everything else. And then we have to fill in formulas, which we know how to get K, the kinetic energy, 1/2 the ball's mass times the magnitude of its velocity squared. And then potential energy would be the formula provided before. We just amend them slightly to suit the new use case. Here we have the spring force, and that force is just spring and gravitational force. I would go over this more, but like my throat is really dry right now, so I'll just like try and get to the point. Delta K's, delta UG, it's just them plus the change, or minus the change in this case. And then yeah, basically we run the program. And this is where my Wi-Fi is really slow. Wow. I'll let that load while I try and discuss the next bit. So that's the glow script code for right now. Sources of error. Let me half screen this. Sources of error in the thing could be me, just human error in general. Like, oh, maybe I did my math wrong, or things of that nature. Possible errors could also be with Tracker, because Tracker was deciding to be really dumb while I was doing my stuff. Great games, by the way. But then there's just rounding errors when it comes to calculation in general. Like maybe I should have been a little more precise in my things, but then also just again, probably the biggest one would be human error. I make mistakes. But yeah, now we can look at our glow script code. So it does its little drawing, but I'm pretty sure mine cuts out for some reason. I don't quite understand why. But so we have our change in energy versus time graph, which oscillates like a mess around 0. And then we have the position and time graph. It shows its model kind of oscillates, but it doesn't oscillate perfectly at all. And then our experimental for some reason doesn't oscillate, and I don't quite get why. The y position versus time, that should be oscillating, but for some reason my experimental shows up all the way here, which ruins the scale and makes it look like it's running very constant. But it is oscillating. The model is oscillating. The experiment for some reason isn't, which I don't know. That could be something to do with the glow script code coming in, or just at least with this one I can say the scale is screwing with whether you can see if it's oscillating or not. But with this one right here, I don't quite have any excuse for it. So that's the comparison between the two. The model oscillates, the experimental doesn't. I don't quite get why, when in this one it shows that the experimental is oscillating. So that could be also why I said there's some issue with glow script, or the way that I decided to put it in. So what does it mean? We have some questions. Was the energy principle satisfied? No, because if you look up here, kinetic energy can never be negative. And if we follow the blue line, it becomes negative every other little mini wave, every trough. So that means as far as conservation of energy, or just like if the energy principles are upheld, they are not upheld. And oscillation periods, so we can use the tracker data to look at that. Let me place it right here. The oscillation is around 1.5 normally, 1.5 to 2 per. And then it's the same here. The oscillation period is like 1.5, and then it gradually gets closer and closer to 2. But those little differences with how they work between like 1/2 and 2 would be the difference. Those differences could affect how the initial conditions were calculated, and that discrepancy could also be a result of human error, just like maybe I tapped the wrong positions, this and that. But that's everything. So the end. I hope you all had a good spring break because I'm pretty sure we grade these afterwards. But yeah, that's all. Thank you.